the rest of the team for having me back. Wonderful to be back, second year in a row. As Jim mentioned, my name is Nikhil. I'm the CEO of Fennel. Fennel is a modern real-time feature engineering platform. And today I'll be talking about data and feature quality and what we do for that in our platform. A bit of history about Fennel. So as Jim mentioned, early on in my career at Facebook, I was closer to applied machine learning. I was running a group of 100 or so ML engineers, and my team used to use various ML infrastructure tooling built by Facebook, and used to run into all sorts of issues with some of them. In the second leg of my career, I was working on PyTorch, building this time ML infrastructure, but not just for Facebook, for the rest of the world as well. And both of these were transformative experiences. The first one taught me a bunch of things about things that actually matter in practice, and the second one told me the importance of building high quality platforms and really good developer experience that PyTorch is known for. I, along with my other, some Facebook colleagues, started Funnel, and the moment we did that, we got a bunch of support from, who's who of industry. People like Adam, who was ex-CTO of Facebook and is on OpenAI board. Kevin, who's CPO at OpenAI. Neha, who's one of the three creators of Kafka. Mikhail, who was CTO at Yandex and recently was running Bing under Satya Nadella. People of, that credibility started believing in our team, our technology, and started opening our network, their network to us. And between our network and their network, we have scanned, hundreds of companies and mapped out the full space of problems people are into when feature engineering is involved. You have probably heard about most of these today from other speakers. They are ease of authoring of features, especially with real-time machine learning, data and feature quality, reusing features, catalog discovery, compliance, cost, all of those things. I will not be touching most of these. Instead, my focus today will be on data and feature quality. So let's maybe ask ourselves, why are we even having a discussion about it? My experience, which I have now since validated with a bunch of engineering leaders across the industry, is the moment you are running at scale, and by scale I don't even mean Facebook scale. I mean the moment you have few models being trained at any point of time, 3, 4, 5% data science team, some real-time components as well. Something or the other is always failing. Your pipelines aren't working the way they're supposed to. Something breaks, and then models don't perform as well as they were supposed to. When you trained them, or they used to work well, and then all of a sudden they started regressing. Real story that I was once upon a time was running video search efforts at Facebook, and I was running a team of I think 30 or so ML engineers at that point of time working on video search. And the single most impactful launch my team had in a 6 month period was discovering that a feature pipeline was setting a feature to be -1 and was basically not computing the value correctly at all. And fixing that was the biggest model improvement we saw across an organization of 30 people working full time for 6 months. So these things are really important, and they show up in real business metrics. But unfortunately, for most of the in-house systems, these are an afterthought. When we built Fennel, we knew from our experience that this needed to be elevated to be a top-level architectural goal, and so we laid in 8 pillars of data and feature quality. And our approach, we literally enumerated all sorts of outages and issues we had seen in our experience at Facebook. And for each of them, we asked ourselves, what is an ideal preventive tooling that is not super intrusive, but still prevents you from, making those kinds of mistakes. I'm going to walk you through these 8 next. First off, we have strong typing. We have a strong typing system, optional types, recursive types, generic types, struct types. You can do funky things. You can take a regex that describes a zip code and then build a type out of it. And at the type system level, you're now guaranteed that this column can only have, valid zip codes. And this, extremely simple, goes a really, really long way. It allows us to catch data quality corruption issues right at the edge before they start polluting the rest of the features downstream. So we have strong types, but then our pipelines themselves are strongly typed as well. So in the middle picture here, you're seeing a pipeline, how funnel pipelines are written. These are very Pythonic, native functions. So here you're joining some data sets, transforming, dropping some columns, group by aggregate, all of that. And each of these operators gives back a typed data set. And if you were to use them in a way that is, types are not adding up everywhere, you would not be able to even commit this data set to Fennel. And so types are present not only in the system at the data level, but the pipelines are strongly typed. And not just that, when you're doing compute, you have the ability to fall back into general world of, pandas. But if you look at the rightmost picture, if you want to compute something, we have an expression DSL, very heavily inspired by Polaris and somewhat inspired by Spark as well. And all of these expressions themselves are strongly typed as well. So for instance, amount half is going to be column of amount divided by 2 as type of float. We know at compile time that this quantity is going to evaluate into float or int or string or whatever. And if you're doing some, or maybe there are some cases where it will be null and your computation is going to fail and will not even let you commit those things. And at compile time, we are able to catch all of these typing issues. This catches a whole bunch of issues. This in itself is like a really big part of our story here. But then we also have native support for data expectations. Here you are defining a Fennel data set, and right next to the data set inline, you are able to describe your data expectations. This is built on great expectations, except we adapted that to work for both batch and streaming data. And types are, row level constraints, that this is a valid row or this is not a valid row, whereas expectations are distribution level constraints, that some rows out of this range are fine, but not too many of them. Some null values are fine, but not too many of them, and so on. And since we built this on great expectations, and obviously we support alerting monitoring on this, uh, people are able to catch all sorts of other issues. And since it is in line next to the dataset definition, acts as a documentation as well. Versioning and immutability, I think everyone in this room would probably swear to that. Versioning and immutability are really important. The specific issue that we wanted to target through this is a model was trained with some features. Then someone came in, refactored the pipeline, possibly in a good intent, possibly believing that it doesn't actually change the meaning of the pipeline at all. But in practice, it does modify the distributions a little bit. And now your model that was trained on a different distribution of input features isn't behaving the way it was supposed to originally. To combat this, every asset in Fennel is versioned, as you can see in the first line here, and all versions of all assets themselves are immutable. So you cannot change them even if you wanted to, unless you are incrementing the version. And by allowing you to maintain multiple versions simultaneously, but not mix them in weird ways and keeping all of them immutable, a whole class of production issues are caught by Fennel's system. Next one, this is probably my favorite on this list. It is 2024, and most people who build production pipelines for data using Spark or Flink or other things, most of them are not unit tested right now. And it is unbelievable to me that hundreds of millions of dollars of business is done on these pipelines, and they have no protection against them. And we believe that happens because writing tests for these things is really hard. We made that really easy at Fennel. The way we did that is we built all of our Fennel engine twice. First in Rust in a distributed manner, efficient, and all of those good things. But then second time we built it directly in Python in memory. It is not persistent, it is not efficient, it is not scalable, but as a full feature parity on all the APIs. So here, as an example, you import this mock decorator that Fennel exposes. You're writing a regular unit test. You could have used nose test or PyTest as well. You put this mock decorator here. It gives you a fake client object, and you now have the full power of Fennel. You can create complex data sets, pipelines, put dummy 3 rows in A and put 5 dummy rows in input data set B, and on the other side, make an assertion that you are getting what you're supposed to get. All of it is completely in memory. You could be on a plane, it would work. All of Fennel surface area is unit testable. There are no parts of it which you require a real Fennel server for testing. And we heavily encourage test-driven development. Not only it raises the quality of your pipelines and your production systems, it also makes your development workflow really fast. So the way it looks like is you make some change, run a test, 10 milliseconds later, you know it is not working, make a change again, go back, run the test again. And that loop becomes extremely fast-paced. Compare that to writing some code, running a Spark pipeline, waiting 10 minutes, realizing something went wrong, and then going back and making a change. So unit testing is another important pillar of our approach to data quality. Then we have compile time lineage validations. So every time you make a change, you have to issue an explicit commit object, and we'll talk more about that in a minute, that describes what you are changing. And at the commit time, Fennel server can reject a whole bunch of changes if something does not look correct from a compile standpoint. So for instance, if someone is deleting a data set, that someone downstream depends upon, clearly it is an invalid change, and Fennel will prevent that from happening. And the fact that there's a single engine that is aware of the full lineage end to end across hundreds of your features and data sets and so on, and is able to enforce the discipline, that is really really powerful and magical. Type mismatches, circular dependency, all sorts of weird issues are caught at this stage. Once again, the compile time before any computation is even done on any of this code. Then we have structured metadata and ownership. Many years ago, I worked at Quora. I was given a job of improving the engineering excellence at Quora, and very surprisingly, we found that just assigning an owner to every module of code was one of the most impactful things we did. Because when someone's name is attached to a module, then they feel a sense of ownership towards maintaining it. If someone is modifying it, there's a clear natural code reviewer for it. If someone is moving on, maybe leaving the company, leaving the team, they know they have to hand over this thing. It becomes a checklist at the exit time and so on. And so all these benefits come from having a human reviewer and other structured metadata flags around tags and deprecated status and so on. And then obviously we tie that in Fennel console and actually give you real utility out of it. You can get real discovery, browsing experiences built on top of that that are really powerful. And so there's real value for people to maintain this. In fact, ownership is something that we mandate. If you try to create some feature sets or data sets in Fennel without having a clear owner, that would be caught at compile time as well. Now, this is another very cool thing. That's a relatively recent addition to Fennel. So one common mistake or source of mistakes I saw was, there's a production pipeline. Someone wants to, make a change to that. And so they ideally want to fork that and change that. But there's a, whole bunch of things that are just ingrained into the pipeline definition itself. Like where does it read from? Where does it write? Maybe in development, I want to write in some other place and so on. And so people would inadvertently introduce changes in production systems. To prevent that from happening, at Fennel we built a Git-like branching system where you can have multiple branches. Each branch is stateful. It has data sets and pipelines and so on. You can clone a branch. Now you have a second branch with the same 100 data sets and pipelines, but these are logically independent views. Changes made to one would never impact your data sets and pipelines visible from the other branch. What is more interesting, however, is the branches are copy on write. So when you clone them, the system is smart enough to know that even though these are different logical views, fundamentally they are the same data set. And so I don't need to redo any computation. It simply increments a ref counter in some places. But when you modify one of those 100 pipelines in, let's say, second branch, only compute worth that is now started. The original branch is still unaffected. The remaining 99 data sets are still shared between them. And this workflow makes development really easy. You can now give a branch to every developer. You can give a branch to every project. You can have multiple branches per developer. You take a branch, start some backfilling, clone a different branch, start a different backfilling, go back home, and when you come back tomorrow, both these independent branches are ready for you to do your experiment on. And within a branch, we remember the full commit history of all the changes that have been made to it. Who changed it at what time. We generate commit hashes and summary objects and so on. And so what infrastructure as code does for infrastructure, Fennel does that for data pipelines. Where everything is version controlled, and you can exactly know what the state looked like for any branch at any commit point in the past as well. We also do feature drift detection, where for literally every single feature, without any instrumentation, we are tracking its mean, its standard deviation, and generally, distribution over a period of time in real time. And so, and then you can set up alerts on this quantity as well. So this is literally the graph for a single feature. And you can see here that the mean, has been well behaved more or less, but standard deviations have become wider compared to what they used to be. And these are the kinds of events that I wish my team had the tooling for to get alerted in my prior career roles. So these are the 8 primitives we are building for Fennel. Fennel, in addition to focusing on data quality, has best-in-class developer experience, powerful streaming capabilities, the whole 9 yards. And I'm happy to announce that we'll be releasing Fennel in open source very soon as well. So for those of you who would like to take it for a spin, feel free to reach out to me. My email is nikhil@fennel.ai. And for everyone else, thank you so much for your time. I would like to stop here.